it locally, and then I'll send you the file. So yeah, welcome to what I think will be the last PICUP webinar for the term. We're very happy to have 4 physics faculty talk to us about ChatGPT and physics teaching. So yeah, I'll kind of quickly introduce Duncan Carlsmith at Wisconsin, Walter Freeman at Syracuse, Jay Wang at UMass Dartmouth, and Colin West at CU Boulder. And each of them will kind of talk a little bit about their experiences with ChatGPT, AI, and physics teaching. And then, as some of you already know, especially those who pre-registered, we have a few questions that have been kind of submitted to us ahead of time that we'll kind of like address at the beginning, or after the panel at the beginning, and then I'm sure there'll be other questions that follow in kind of the kind of Q&A portion that'll wrap us up. And yeah, I guess I'll just say, like, when the time comes, if there are questions, feel free to enter them in chat, or maybe use the raise hand function just to kind of keep things organized. So yeah, with that, I guess we'll go ahead and get started. We'll start off with Duncan. Yeah, and I think you might, yeah, he has a presentation for us. We can see your screen, but okay, yeah, now we can hear you. Yep.
All right, great. I was muted. Okay, great. Yes, get rid of this. Well, thanks for having me. It's a pleasure to lead off here. I'm Duncan Carlsmith, a physics professor at University of Wisconsin-Madison. I give a little talk that I just put together recently and gave to a Minnesota group in AAPT on AI-based code generation and implications. So let me just slide you over here. Sort of a long abstract. The talk won't be nearly as long as it looks. So OpenAI's ChatGPT, Bing, and Bard actually generate simple computer codes based on plain English prompts, and can translate from one coding language to another, and even translate straight out text-based math in various formats right into code. So that's really cool. And you all know, I'm sure AIs are changing the programming landscape, but other landscapes generally. And I think I will facilitate incorporation and computation in the STEM curriculum. That's really what I'm going to focus on. So I'm going to tell you, provide you some illustrations. I won't be able to talk about them all, but I'll give you the resources for use of AIs in ad hoc program code generation, and translation of math from LaTeX, PDF, and Mathematica, and Python straight into MATLAB. Translation of English code to French and Turkish, and some other crazy stuff. Why am I interested in this? And some of you know me, I've been teaching a course, introductory physics using MATLAB, automatic honors course for about 80 first-year physics and MEP and physics astronomy students. And I've done this by incorporating live script tutorials and MATLAB data analysis for the laboratory. There's no prior coding experience, and we do all kinds of crazy intermediate and advanced level stuff and dive right in. Give you an example. This is one of the live scripts that the students use in their first semester. They go off and download raw data from the LIGO Gravitational Wave Observatory and crunch it themselves. What I'm showing you here is a link that you can find to this particular script, which is all the ones I'm talking about being MathWorks File Exchange. And if you do go and look at one of these, if you click on examples, you'll see this executed. And if you click download, you'll get the script, of course, in a PDF. So if you're not a MATLAB person, you can still, see what's going on. This particular script, you can see the kind of the format. It has a hyperlink table of contents, and does all kinds of fun things. And I put in for assessment, I put in various challenges, try this suggestions. What this one does is it actually imports the raw data and then identifies all of the mechanical resonances that are contributing to the signal, kills those with a multi-notch filter, and then compares the data to the publication that got the Nobel Prize some years ago. So it immerses the students in big data as well, learning various tricks, in this case, signal analysis. So, here's a host of other scripts, just to illustrate, and then I'll end there. Things that, students suck the data out of their Pasco lab stuff and analyze it themselves. They do fun stuff. They explore asteroid shapes and grab exoplanet, raw exoplanet infrared observations and discover exoplanets for themselves and so on. So what do? They take a free 2-hour course on the cloud, and they're up and running. And I provide them tutorial scripts. So they come with no coding experience, and they're learning a lot of pretty heavy stuff. And I work very hard to make my scripts, documented, hyperlinked, and so on and so forth. But writing their own code is, really time consuming. So, and I really think AI assistants will use this. So just to illustrate, how you can use ChatGPT, kind of a workflow. You bring up Google and ask for code. This is a simple thing like, how do I generate an XLS file, say a calendar? And if you have the Chrome extension installed, ChatGPT pops up, it provides immediately. It's responding all the time. It provides immediately, explanation about what code, use write table in the MATLAB, blah, blah, blah. And, there are all these other links. You can ignore all that stuff. There's a little button that you just copy the code. And the code is listed down below. I didn't show it all. So, you bring up the IDE for MATLAB, and you just go down here at the bottom right and paste it in there. So you did a copy paste. Later, I'll tell you how to do this programmatically. And you hit the run button, and it works, just like that. And this one makes an XLS file. You see after I ran it in the upper left, it's the file space. This calendar was created. If you want, you just edit in some text on the top to make yourself, your own live script, and you can paste, images and stuff in there. So you can see how this would, could serve a student just trying to learn something about how to do code. They can just ask in plain English and voila. Well, that's not very physicsy. How about we ask MATLAB to give me some ChatGPT MATLAB code, please, to simulate and analyze a ballistics experiment. That's the entire prompt. Okay. And you can see, I actually did this one by logging into OpenAI. You can see the code. That was its first response. And, I copied and pasted it into a live script, as you can see in the upper right. You see it comes, there'll be an extensive verbal commentary surrounding this code in ChatGPT, but it actually generates code with embedded comments in it, right? So you can see this is the, there's comments. It went and chose realistic parameters for everything. In this case, it decided to, numerically integrate the equations of motion for ballistic motion with drag, nonlinear drag. And it does numerical integration. And it decided to plot the result. I didn't ask for that. I've done this differently and asked for it to fit the thing, simulate data with errors and fit it, and it just generates that in an instant. So this is error-free, except there was one thing that needed to get commented out, give you a sense of what it does. So a student is running the first lab and they're doing experimental ballistics, they can just ask for the code to simulate it. So I don't have time to talk about all these things. Oh, I didn't set my timer. Hope I'm good. You can go and see some of the experiments I've done. These are live scripts, and again, you can just read them there. Trying Bing, doing some fun stuff, comparing with Bard. You can give it code and say, explain this for me. So if somebody passes out some code and they don't know how it works, they didn't comment it enough. Well, ChatGPT will explain it to them. You can generate code in French or Turkish. I mean with Turkish variable names, as well as translate all the comments, which is really cool. And you can actually have it turn all the comments into poetry if you want, in Turkish, which is fun. You can translate Python to MATLAB, and this script shows you how to do that systematically, using an API, going to a repository and translating some, bunch of Python. A really cool thing I discovered is you can just drag and drop PDF onto ChatGPT PDF that maybe contains some equations and ask it to convert all the equations to code, and it does. That's really fun. Yeah. You can talk to Wolfram Alpha through an API and get, text-based math and just translate it into MATLAB code or Python code or whatever you want. So there are a bunch of scripts here. And you can go to the file exchange as shown here. This is one, generate unit-tested MATLAB codes. So in this case, I'm calling through an API, ChatGPT, and if I get a code that has a little bug in it, well, I just throw it back and say, fix this, and it fixes it. So click on examples to view it and click the download button. So what this allows us to do, is kind of give you a sense, but, I think it's really great because students who have no coding experience can get up to speed in a hurry, and they can really focus on higher order thinking and essentially write pseudocode and not have to spend all the time, messing around with syntax and stuff. You can ask for a live script and you get live script stuff too. And it's not just for STEM. Here's a code I asked it to, give me MATLAB code to with an API talk to Pew Research, for example, to find out what the next election is going to give me. And here's the code. And it warned me in the comments that I did that, came along outside the code that, I would have to replace this question mark with my own authentication. So, yeah, I mentioned you can have your code comments be limericks and, have all kinds of fun. So I hope this, gives you a sense, if you haven't played around this way, of what you can do with AI assisted coding. I think students can learn computation and mathematics by doing science now faster and better. And if you want to find these things, you can just Google MATLAB file exchange Carlsmith, or if you can remember this link, I can put it in chat if needed. You can find all these scripts out there. And that's it.
Well, thanks, Duncan. As I said, we'll have time for questions after each panelist kind of gives their spiel. I think I saw a question in the chat, but it looks like it was addressed by Walter. So yeah. So I guess on that note, Walter Freeman from Syracuse, teaching associate professor. You want to talk a little bit about ChatGPT?
Sure. And I actually I am not an expert in ChatGPT or machine learning or artificial intelligence or language models. I have thoughts, which I will share my thoughts, but I want to, full disclosure, not at all an expert in this. What I do want to speak about is the concerns that many people have about not AI being artificial intelligence, but AI as academic integrity. This notion that students might not be doing their own work. Although, actually, I want to, before I say something about that, there's a question in chat from Panoff RM. Said, how do you help students ask and answer, how do you know if it's right? And that's a wonderful question. And I'm reminded of one of the most lucid things that I've seen said about ChatGPT by someone who is a true expert. And she said that ChatGPT is not particularly calibrated to produce answers that are correct. That's not what it is designed to do. What it's very good at is producing answers that appear to be correct. And that is what the machine learning has tuned itself to do, right? And if yes, Colin, that's actually because of I teach extremely large classes, and that's usually where I encounter the acronym AI is, oh crap, a student cheated on an exam somewhere. I'm something of the physics department's expert in that, and I'll talk about that, why that is in a minute. But these language models are very good at producing answers that appear to be correct. And of course, appear to be correct is a loaded term, right? Things that would appear to be correct as understood by the collective wisdom of all of the training data. So if there is a standard problem where what is correct, what appears to be correct is correct and that understanding is widely disseminated, like projectile motion or Python code to do things that people have searched for how to do before, it's very, very good. There's a student a graduate student who brought to me her cell phone, and she said, I'm concerned we're all going to get replaced by computers. Look at this. And she had her cell phone and typed in, asked ChatGPT to write her some code, and here comes some Python. And I said to her, ask it to write you a code to do Markov chain Monte Carlo for the easing model. Here comes all this Python. And then I said, have it do it in Perl, which is a computer language that has somewhat fallen out of favor, but that I still use every day. And here it comes translated into Perl. But that is a standard task, right? And I think one of the things that I would advocate for transparency more than anything else with students. Be transparent with them about what these machine language or machine learning models do and what they don't do. They are very good at accumulating knowledge, right? Accumulating things that have already been found out. So as Panoff says, how do you know if it's right? Well, if the knowledge of whether a certain thing is right or not is widely disseminated, or at least whether a certain thing would appear to be right or not is widely disseminated, ChatGPT is great. It is not great at asking it to do things where the evaluation has not been done before on the internet many times. It's better than we think, right? But that's what it's not good at, is the novel generation of knowledge. And this is kind of where I want to pivot back to the academic integrity issues, which is what I've been closer to. Often we ask students to do things as part of their education where the answers are known. We have standard problems, right? Everybody, the bass bouncing on the spring and the projectile motion question and the easing model for Markov chain Monte Carlo. These are standard exercises that we have our students do, not because we're interested in them doing novel knowledge generation, novel to the community at large, but because they will have the experience of generating knowledge that may be novel to them and practicing the skills that they would need to then generate knowledge that is novel to the whole world, right? And sometimes this context where the faculty member designs a certain experience for them, knowing how it will come out, and they don't already know how it will come out, is part of their training process. And so ChatGPT, right, it has the synthesized experience of the surface level synthesized experience of the world's physicists. So if students lean on that, they circumvent the designed for them training of giving them an experience of doing knowledge generation that's novel to them, but not novel to the world. I actually think that ChatGPT reduces the issues that academic integrity violations cause. That is going to be probably a radical thesis, in that the widespread use of language models makes students' educations harmed less by cheating, at least in physics. In the spring of 2020, the pandemic semester from hell, I was giving a class to over 400 students at Syracuse. This was intro engineering for physics majors. We all went online. A bunch of our people went back to China. Had a lot of Chinese nationals in our class. So our final exam, I gave them a 24-hour take-home. And they had to sign a statement on the front of it saying, like, I did this exam myself, basically. I followed the rules. Within 1 hour of us providing the questions of this exam to the students, some of which were completely novel, most of which were completely novel, someone had paid the website Chegg. So Chegg is basically a site where people can, through kind of a pseudonymous process, hire someone to do their homework for them. It is, they act like they're a legitimate study business. They are not. They are used 99% by people who want someone else to do their homework for them. And within 1 hour, someone had hired solutions to those exams questions, and they were posted on the internet for anyone who had paid Chegg to see. over half of the class, so over 200 people, cheated on that exam because anyone with a Chegg account or anyone who knew someone with a Chegg account could just get the answers because someone had been paid to do them. One of them was hilariously wrong. So, you know, the person making the solutions, right, they did not, you know, they messed up some algebra, you know, got that a ball ran up a ramp that was 1 meter long and landed 90 meters away. And, you know, that was bad, right? But, and students, every time you assign a homework set, every one of you, every time you assign a homework set, the percentage of students that hired someone on the internet to do that homework set for them is at a minimum 20%. That is what happens when we give our students homework. And we are kidding ourselves if we say that that's not happening. It has been happening since I have been teaching physics. And the reason that I think ChatGPT does not that it does not represent a new harm to students' learning process is that when you ask ChatGPT to do something, you are not getting a hastily written solution written by someone working on commission who is getting paid by the solution. You do not get a page of scribbled algebra. You actually get language. ChatGPT, it makes mistakes, right? It's not perfect. It makes kind of very interesting mistakes when it makes mistakes. It generates language. It generates English or Turkish or Limericks or whatever you want it to do, right? But it explains what it is doing in a way that is remarkable, in a way that only our very best students will actually do, right? We all have the frustrating experience of students, you ask them to do something and they just give you a page of algebra that may or may not be right and don't justify what they're doing. Yes, Jay West, in Chegg's latest earnings report, their stock was down, I think, 30%. It slammed their stock. Their earnings report, basically, they said ChatGPT is putting them out of business, and their stock tanked. And I'm happy to hear it, right? If anybody knows Avenue Q, I was singing the song Schadenfreude for Avenue Q, which I'm sure ChatGPT would, you know, helpfully tell us the etymology of. But the answers it produces contain well thought out, well reasoned mixtures of language and physics that few students have the literacy to produce. And if students go type their homework into ChatGPT and actually read what it produces, the things that it produces are actually, they're as lucid as the things that my TAs and I write ourselves in many cases, simply because they mix language in with the physics. And if the students actually take time to read the stuff that it spits out, they will learn more than just the scribbled algebra that they'll copy off of Chegg. We know that students at home with access to the internet will often turn to the internet to generate homework solutions for them. And they, you know, in doing so, of course, they're depriving themselves of the educational experiences we've designed for them, right? Where they generate knowledge that is novel to them to learn from. But if they're going to deprive themselves of the experience of actually having done the thing themselves and instead have something else do it for them, I would argue it is much better for them to engage with a chatbot that generates physics reasoning in language than for them to copy things that are totally alien to them that they don't understand. So that's kind of the defense of that radical thesis that I think ChatGPT is actually, in putting Chegg out of business, means that students who don't do their own homework actually aren't going to suffer as much as they did last year. So there's my radical claim. I'd be interested to hear anybody's comments about that.
Thanks, Walter. Yeah, I mean, I think a lot of us are probably coming to this from just the academic integrity point. So yeah, I appreciate the insight. So yeah, and I'm sure there will be a lot of discussion after our next two panelists. So yeah, so maybe we'll have Jay kind of talk about his thoughts. Jay is a professor of physics at UMass Dartmouth. a member of the PICUP community, and he's interested in computational physics and research and how to integrate it in his teaching. So yeah, go ahead, Jay.
All right. Okay. Thank you. Can you hear me okay?
Yep, we can hear you.
Okay, very good. So like Walter, I'm also no expert in AI or ChatGPT. In fact, I didn't even know ChatGPT until about January of this year, when some of my colleagues were talking about it, and then my students were talking about it. So I started to look into it and found something sort of, is scarily good at some things and not so good at some other things. So I wrote up a little bit, a short letter, and the AJP editor liked it, so it's published. So I'm going to talk about the things that, I discussed in that short letter. So Walter said, students in our classes want them to learn basic things. So I basically want to look at how ChatGPT does with regard to some specific, very basic questions. And of course, the first thing on our mind, right, is, oh, this is obviously a cheating tool. And I want to talk about that is probably the potential is more than just, that. I think it could be a useful tool helping, us in the classroom. So the first question, you put in chat, I put in ChatGPT is just a problem worded very vaguely. That is, this Q1 here, it says solve the motion of body on a frictionless incline. And so you type this in, and other than formatting, this is exactly response, ChatGPT gave. So in one response, you talk about how to solve the problem following the, several steps. And, talks about the parallel gravity, the force of gravity downward, perpendicular to the incline, and so on and so forth. And in the end, gave us the acceleration, okay, which is what we want. And furthermore, I gave this basic, how you can plug this acceleration into the kinematic equation, and so on and so forth. So if I was looking at this as a student response, as homework assignment, intro physics, I would give a definite 10 out of 10. It's really near perfect, So in ChatGPT, you can, for the same question, you can ask to generate different response. So the next one here, R1B here, is a different response to the same question. So here it has this, it says, okay, you have the acceleration is that, okay, Y acceleration is this. And here you see that ChatGPT has what I call information or maybe quote unquote knowledge, but it lacks sort of contextual understanding of what this means. See, this Y acceleration says it's negative G cosine theta, right? And it's not understanding the fact that, the motion is along the incline, there's no motion along the perpendicular direction. And if you look at this as, breakdown of G in some slanted coordinates, you would get this, but this is not the context within which we're talking about, right? So, and then later I found out that I actually read a paper that talk about this being the thing that ChatGPT is good in sort of regurgitating information, but not so good at, putting the information in some contextual understanding. So now having done that, I then asked, okay, same sort of question. Now let's take a look at body on a incline that has friction. Okay, so the question is posed like this. We have a body at rest on an inclined plane. And so we'll raise the angle slowly such that, the body is just on the verge of sliding, find the maximum angle. Here's interesting is that ChatGPT, in the first response, it just gave this formula, okay? Mu s is the static friction, and then tangent theta is just equal to that number. So this is correct, obviously. I think it just, is training data there, this information there. But if I saw this in the student homework, it's correct, but, there's no explanation where this came from, right? So probably worth like 8 out of 10 if I were to grade it. But I didn't specify, the you have to show work. So maybe, you could, student could argue that they should get 10 out of 10. Now, then I asked this, since we do, computation in, we integrate computation into our class. So I asked the same question, basically just then added, write the Python program to find maximum angle. Now you had already seen, Duncan showed the capability of code writing capabilities of ChatGPT. And I just want to briefly show you this code. In fact, I was thinking this, I was not expecting that you will write the code in a primitive simulation format, so to speak. So you see this loop here, what it's doing is it's actually starting the inclined angle from 0 and then incremented in 1 degree intervals until you find this parallel force of gravity overcoming the static friction. So in this loop, you didn't just give a formula and print the results, right? So this is kind of like, it's a simulation sort of. So that was actually pretty good. So now I thought, okay, this formulaic based questions GPT does very well. Next, I tried some conceptual question, you will find quantum mechanics. So the idea there is that, let's say I will have a beam of random spin, okay? And this beam passes a, Stern-Gerlach selecting in Z direction, okay? So then we asked, after passing that, after that beam passes through a Stern-Gerlach selector in the X direction, what is the probability of finding the electron with spin in the positive X direction, right? And so ChatGPT gave a very, as Walter said, very elusive reasoning, and it seemed to be okay, but it says that extra probability in the X direction is 0. So apparently what it's thinking is that, after this electron passes the Z deflector, right? Z selector, then spin up will be, deflected in the positive Y direction, spin down in the negative Y direction, and then it confuses, I think, this the motion in the positive or negative Y direction with the spin. So obviously that's wrong, right? But it's very convincingly wrong. So and then I asked, okay, we're not so sure, shouldn't the answer be half? Now you see another aspect of ChatGPT here. It is actually very affirmative, right? It says, oh, you are right, without any pushback at all. Says blah blah blah, the probability should be half in the X direction. Okay, so now I started sort of want to play with it. I say, okay, actually I think the answer should be 1/4, right? It's just fooling with it, and it says, okay, you're correct. So and then it gives a bunch of reason doesn't make sense. So I think the conclusion that from this very shallow testing of this is that ChatGPT does lack, I think, contextual understanding, and then it can be a really useful tool in terms of coding, but it might even be useful tool in terms of helping students understand some concepts, like the spin superposition. So just I want to share with you that this is an article that I had come across. This is in April, I think. And it talks about, ChatGPT in physics education. So here we have, I know a lot of people that are in PR, and I think, I'm sure you're already paying attention to it, but I think this really deserves a lot more interesting, investigation, formal investigation, and see how this can help us utilize it. Because students will use it. And that's for sure. In fact, I have, so let me just stop sharing here. In fact, knowing about ChatGPT has made me modify my quantum mechanics class I'm teaching at this moment, at this past semester. So for the first time, I had asked students, I gave them a problem. I said, okay, go use any cheating tool you can find, okay? Solutions manual, check, or ChatGPT to solve it. And a fair number of students tried it and reflected on it, and that's what I wanted, to have. But I don't have any conclusion on that. So it's obviously new for everybody, and I think this is the beginning of conversation where we should get a handle on it, and using that. Somebody says a cat is out of the bag. We cannot just pretend that it's not going to be there. So that's all. That's my spiel. Thank you.
Thanks, Jay. And yeah, there's a lot of good discussion in the chat that I'm sure we'll have a chance to kind of return to after we hear from our last panelist. And thanks, Marie, for sharing the links to all the papers that have been asked about. So our last panelist is Colin West. He's an associate teaching professor at CU Boulder. He maintains affiliations with both the Physics Education Research Group and the Quantum Information Theorists. And after he gives a chance to present, we'll kind of turn to some of the questions I've been asked, and then open up for discussion.
Hi, everyone. First, I have to apologize in advance. There was a mix-up with my childcare, and so my 4-month-old co-author of sorts is in a bassinet in the background, and this has been going back and forth whether he's deciding to be a good listener or one of those reviewer number 2 style commentators. So we'll see how it goes. I apologize if you hear a crying kid. It'll encourage me to be brief. I guess what I'll share is we'll have some overlap with some of what other folks have said as well in some ways. I have a little condensed version of a presentation I've given a couple places. I guess what I get to add here is a little bit of a focus on ChatGPT, in particular, its conceptual abilities in physics. I think it's pretty well documented. The code is one of the things it's absolutely best at, and obviously this community is particularly interested in coding in physics. But I'll talk a little bit about if you ask it pure physics questions, and then as others have sort of brainstorm or discuss a little bit about how it might or might not be used in our classrooms. I'm very interested in that. I'm teaching a couple classes this summer. The normal intro courses that I teach are hundreds, if not thousands of students, but the summer classes are dozens. And so I'm excited. I'm hoping in the next month here to come up with some good ideas that can be piloted in that small, safe setting before accidentally unleashing something with 1,000 students. That might be a disaster. All that I'm going to say here is really briefly condensed, comes from a couple of papers I have in the archive, and I must point everybody also this third paper down here by Gerhard Kortemeyer at ETH Zurich scooped some of the results that I put in here by about a week. So I want to make sure you pay attention to his results there as well. So I just want to ask, does ChatGPT, is a loaded question, right? Does it understand conceptual physics? That's a question for AI experts and philosophers, but does it project an understanding? That is, does what it puts out into the world appear consistent with understanding conceptual physics? And this depends very much on what you mean when you ask this and how you assess it. I'm going to suggest a couple here. There's a tool in the PER community, I'm sure many of you know, called the Force Concept Inventory, the first of a large family of somewhat standardized and well-studied and validated assessments that we use to target conceptual understanding in physics. And it's a multiple choice item that I adapted to give to ChatGPT. And I tried to assess both its raw multiple choice score and also the score I would give in a free response version where I asked it to explain its reasoning. You could score that various different ways, give it all credit or no credit, or you give it partial credit. All of this, I won't really have time to get into this, but the PER person in me wants to say all of this discussion about trying to figure out what ChatGPT does and doesn't correctly understand in physics is a really useful mirror, I think, for us to hold up and ask, so what do we really mean when we want to know if our students understand physics? And it, maybe features that can easily be reproduced by a large language model are not it, or at least not all of it, and maybe it tells us some things about that, but that's sort of another discussion. And then the core point I want to make down here is it really at the moment depends on which model you're talking about also. The publicly available version is based on the model GPT 3.5, the text-to-Vinci 3, and but there's a subscription-only model, which is throttled and rate limited at the moment based on GPT-4, which was released in, trying to blank now, March. It's only a couple months old. There isn't public API access to it yet, so a lot of the work that you see out there that calls ChatGPT doesn't use this, but it seems to make a big difference. It's in this realm, at least, it's a lot stronger, and I'll show you. So you take the old model, the 3.5 model, and you ask it the questions from the FCI. For this first go around with the old model, I only asked it 23 of the 30 questions because there were 7 questions where I felt I was putting it at an unfair disadvantage by translating the question into text because of the way they depended on figures. And it does okay on this. It gets about a 65%. And 2 of the questions it got wrong, I felt kind of bad about because their questions were sort of technically, the canonical answer in the FCI is wrong. It depends on assuming that air resistance is negligible for a dense object that only moves a short distance, which is a fair assumption, but it's not incorrect to say what it said. So it's somewhere in a pretty good range there. This was above the average post-test score for my students the last time I taught a large intro physics course and gave this same instrument to them, selecting out those particular items. And what was neat was that its correct answers are pretty stable. As you know, there's a stochastic element to this system that's sort of the equivalent of like a numerical solver. You start with a random state vector or something like that, so some random initial guess. The random initial parameters and then the random temperature selection along the way introduces some variability every time you ask it. But you can repeat the question either with the same prompt or with variations in the prompt that shouldn't change the underlying physics. And I found that when it got the question right, it tended to get it right 9 times out of 10 or not more under either of those types of perturbations. Here's the pre-test distribution and the post-test distribution of my students on these particular items. And ChatGPT based on GPT 3.5 falls in these bins here. So it's well better than my students before they take physics. And it's about as good as my sort of B- students after they take my physics class. Maybe that reflects more on me than it does on ChatGPT. I'll have to be careful about how I interpret that. If I give it the chance to explain its reasoning and I try to score its free response questions on that with some kind of standardized metric, I found that fewer, but still a healthy number were what seemed like perfect to me, flawless, exactly how I would have described or how an expert might have described the answer. And then another group of them were near perfect. These near perfect responses were perfect, and they usually had errors. If you've played with ChatGPT, you've probably noticed this sort of pattern with physics. When it makes a mistake, the mistake is often surprising in the sense that it doesn't look like the kind of mistake that a student or a near expert in the field would have made. It's a really out of left field mistake. They're often also unforced. That is, they appear in aspects of the response which were not strictly necessary for answering the question. It will sort of go off on a tangent and say, it should be noted, by the way, that G is constant in this context. And then I have to say, well, technically, no, it's not. Now you went out of your way to say something false, and then there were another 8 questions which were just nuts. They were just, the grammar is always correct. But they're sort of the physicist version of the furious green ideas, sleep, whatever the sentence is, right? It hangs together, but then you try to track its reasoning, and when you look at the details, they just don't connect at all. The free response questions, I can't tell you how it compares to our students because I don't ask my students to give free response questions on this item, but I can tell you just qualitatively in my experience, I really doubt that my median student would perform this well, at least on the free response questions. So that's the old, widely available version of ChatGPT. If you bump up and pay the $20 a month for GPT-4 and repeat the experiment, and by this time I convinced myself it was worth using all 30 items on the FCI to allow me to compare it to Gerd Kortemeyer's work and some other things, and because the 7 questions that I was excluding, if anything, were going to be worse, the machine was going to be worse off. So I thought at a minimum, this will give us a conservative baseline. That version of the model gets 28 of the 30 questions correct. And in fact, one of the questions that it gets wrong is still one of those categories where I think, technically its answer is correct here, but it's not doing an obvious human thing and ignoring treating as negligible air resistance in a problem about pushing a piano across a room. All of us naively assume, yeah, okay, well, nobody means to talk about the air resistance on the piano in that problem. That's a friction problem. It doesn't do that, and it gives you the answer that it would be correct if there was non-negligible air resistance. So maybe we should even give it 29 out of 30. That would be at least the 96th percentile of my students' post-test scores. It would be among the best of my students after taking my class. I should take a moment here to say, whenever I talk about this, people ask me, aren't these things just all in the training set? There may be some truth to that in a sense, but actually I think this is a particularly good item for testing this because people have gone to some lengths to try to keep the FCI items and their solutions somewhat guarded. They haven't succeeded, but where they exist, they're generally behind paywalls, or they're often in handwritten Chegg type things that we know it doesn't have access to, or they're separated from the questions. And so for a number of reasons that I go into in the preprints, I think we can be fairly confident that it's not that there are not many copies of these particular questions and their solutions in its training set. And I think that's supported by facts like the fact that it still gets these correct when I switch up invert the grammar of the sentence and change ball to stone, change boy to girl, change north to west. You can switch up the details and it still understands it. But if you're asking, are questions like this all over the training set, the answer is probably yes. And that sort of goes back to what Walter was saying. In introductory physics, conceptual physics, we're asking it questions for which there is a well-established expert consensus out there that has been much discussed in many contexts. And what's impressive, I guess, is that it can potentially take these other contexts and apply them in somewhat novel physics context. Let's see. The GPT-4 answers are extremely stable. It gets almost all of them right, and it gets almost all of them right almost all the time. It would be in these bins over here. It's really good. And I think this improvement is notable. It was a relatively small amount of time that passed. It's not totally clear what changes they made in the model here. They were a little cagey about this in the paper announcing it, but it was not a dramatic change in structure. It was just more training data and more, what's the term they use for the human-enabled feedback, training feedback. So the free response version was also very good. Not quite as good as its multiple choice response, but nearly all of its responses were expert perfect. A few were imperfect, but these were really nitpicky imperfections. They were all unforced things. One of them I dinged as imperfect because after correctly describing the motion of a rocket with firing thrusters at various times and things, it casually referred to the motion as diagonal at the end, even though the rest of its description told me quite clearly that it knew that it was following a curved trajectory. So it's little stuff like that. There was one that it totally missed. This was one of the problems that in translating it from the FCI, I had to introduce a computational aspect. All the other questions were purely conceptual, and it does the calculations correctly and then draws the wrong conclusion from those calculations. So that one was a big whiff, but it was its only bonkers response for the new model. I want to show you just one example of this that I think demonstrates the leap that I see it make from 3.5 to 4 that I think is salient. So one of the questions that adapted that I asked it here is this one: take a ball in a string and swirl it in a horizontal plane, and you let it go at a moment when the ball is traveling north. What path does it follow after you let it go? Super classic setup for the question. GPT-5 gets this one, 3.5 gets this one wrong by telling me all the right stuff about what is happening to it and then not knowing how to place that in any kind of physical context. So it tells me the correct idea. It will keep moving in a straight line. That straight line will be tangential to its path. There will be a force of gravity pulling on it, which actually isn't addressed in the FCI question, but that's also a good point. And then it says the downward force of gravity will curve it to the east. And then it says, in addition to this, because it's moving tangentially, it will begin curving to the west. I think it's just pulling these directions out of nowhere. I'll explain what I think is happening here in a second. Compare this to GPT-4. It tells me it invokes all the same concepts here, but it correctly tells me that this particular ball is going north. This is stable across multiple iterations of the question. It's stable across new versions of the question where I switch it up and say, oh, sorry, the ball was moving southwest. It says, okay, now I know the ball is moving southwest. So the GPT 3.5 model, I think it's looking at its training data. It's saying, gee, every time human beings discuss tangential motion, there's lots of discussion of what happens, circular motion. I mean, there's lots of discussion of what happens when you release something from circular motion. They sure say the word tangential a lot. They sure talk about things moving in a straight line a lot when they discuss that. So it must be that it'll move tangentially in a straight line, blah, blah, blah. And then what direction do they typically say it goes? I don't know. Sometimes they say it goes up. Sometimes they say it goes north. Sometimes they say it goes west, because there's like a flat distribution of questions out there that situate the problem in all these various different directions. And so it randomly picks one of those directions as its final answer, and it gets that wrong. But GPT-4 seems to be able to trace a deeper pattern here. It seems to notice that not only whenever everybody discusses these things, they talk about moving tangentially, but then they pick a direction, and that direction is the same one that they invoked in the statement of the problem, or something like on some level, it's able to identify the correlation between those two as relevant also, which the simpler model wasn't able to, and it gets that. And I think that should count in at least some fashion as demonstrating some understanding of physics, because that's, whether its reasons are different or not, that's what I'm asking my students to do when I want them to understand this kind of thing, right? And so I think we should it's easy to put ChatGPT down as a stochastic parrot and things like that. But I guess my point here is at least the latest version of it can really accomplish a lot in conceptual introductory physics for those limitations. So I think it's quite powerful, and we should be aware of that, both as a teaching tool and a tool that our students will inevitably learn. There's a really important caveat to make here, which is that because of the things that were talked about by the last few presenters, the way it's drawing its training data, an easy way for me to stump it is to take these questions. If I switch up the word, but it still sounds like a physics problem, it does great no matter what context I put it in. But if I ask it in a totally different tone, and I don't make it clear that I'm talking about a physics problem, if I say, for example, hey, the other night, my brother and I were rolling toy cars around on the table, and we both rolled them off the table, and I couldn't figure out why his crashed so much faster than mine. Like, I was expecting mine would travel further because it's bigger. What the heck happened there? It fails in a way that it doesn't if you ask the analogous two balls, one with mass m, one with mass 2m, roll with a horizontal velocity v off of a horizontal surface. There's something about the tone that keys it to the correct portion of its training data. So in that sense, it's clearly not demonstrating an understanding, right? I would expect a student who understood physics to also understand physics when I'm talking about physics colloquially. So there are lots of limitations to be aware of here, but there are lots of capabilities as well. The publicly available version now is not so great, but I don't think we should dwell on that as much, because surely the non-publicly available one will be next week's publicly available one or something like that. So I think we got to assume that our students have access to a tool like Walter was saying. It's comparable to Chegg, except it's more interactive and it's on demand. I agree that you can view this as either a bad thing, it's an easier Chegg to Chegg with, or a good thing. It's a Chegg that actually sort of tries to talk to you and is not just interested in some profit-driven thing. Like, it's trying to sound like the experts who have posted solutions to physics problems online, who are physics educators, who are trying to say intelligent and pedagogical things when they post these things online. So that's good. And then some things to ask and to think about. I didn't mean for these all to pop up at once, but what do you do? Can this play a role in our classroom? I'm definitely a big believer, it's not worth trying to stamp it out. And so if I can't stop my students from using it, and maybe don't want to stop them from using it, maybe I should also affirmatively use it. This is tricky because GPT 3.5 based models just don't give correct answers often enough that I'd feel comfortable using them the way I have colleagues in the computer science department who tell me they're starting to run classes where we tell students, just pull up a ChatGPT window at the start of the lesson today, because it's going to be your co-pilot, and a lot of your questions you can ask it first before you ask me. I don't think we can do that yet. At least I don't feel like I can with introductory conceptual physics, maybe with coding and computation physics. But GPT-4 makes me feel like maybe we could. The problem with using this in the classroom, what I really want to do with this, what I'm trying to think to do this summer is, how can I use this, where I imagine this is going is the same place that we've gone with MATLAB and Mathematica. Nobody teaches integral tables anymore because that's not how you do those anymore. So we should teach in class the way to do physics when you need to integrate something that you can't integrate normally, is you integrate it numerically, or you look up a table if you think there's a special function or whatever. We teach all that now because that's a tool. I think we should imagine that the physicists of the future will solve problems by thinking about them and then asking ChatGPT or some sort of AI to help give some feedback, and then thinking about the response and having some dialogue with it. I imagine it like the scenes on Star Trek, where they say, computer, give me all of the planets that could be this. Now cross-reference with that signal. Okay, now eliminate the ones with a nitrogen atmosphere. So I want to start giving students an opportunity to try to learn how to do this. I'm struggling with how to figure out how to do it because I feel like there's an awkward gray zone in its capabilities. A lot of problems are so trivial that if I give them to students and say, work on this as a project with the help of ChatGPT, ChatGPT will just solve it for them and they'll just describe the answer. And then if I find a problem which is sophisticated enough that I think that the students can do it with ChatGPT's help, I can't be confident that ChatGPT will give them correct information. And I'm not sure whether it's appropriate to spend a lot of time teaching them to identify that correct information, or if that's a passing state in the model. I'm not sure. That's something I'd be interested to hear others' thoughts on. And I want to close. The last thing I'll say, I'm sorry, I've been talking for a while here. I just realized I don't have my clock because I used it to play white noise for my toddler. For my infant. If we are teaching them to interact with the model, I think there's 3 types of things among many others, I'm sure, that we need to be teaching students to look out for as responses from artificial intelligences. Some of these are well documented, and one of them I made up. but you can tell me what you think about it. Of course, everyone's familiar with the hallucination effect. It will just make something up which sounds entirely correct. That is sort of a new kind of misinformation that students aren't necessarily aware they need to look out for. And we got to think about training them to do that. Validation bias is a term that I've started to hear bandied around as a complement to confirmation bias. ChatGPT, as we saw in one of Jay's examples, I think will agree with you most of the time, whatever you say. So you can tell it, no, you're dead wrong about that. 2 + 2 is 5. Maybe not something that simple anymore, but in the early days it would do that. And I suppose because its training data is full of human beings who tend to acquiesce when someone tells them quite confidently, no, you're wrong about that, it acquiesces and says, sure, you're right, and tries to explain even why you're right. So we have to be careful about how our students approach ChatGPT. If they have an initial instinct and they just ask it if that's correct, they might be getting much worse information than if they ask it a more open-ended question. But on the other hand, that's tricky pedagogically because ordinarily I would prefer them to express their initial guess, to a tutor or a grad student or something, and then just say, give me feedback on this rather than say, tell me how to do it. So that's another needle to thread. And then the third one here, I've labeled this phantom symmetry. It's a terrible name for it. I just made it up this morning. It's a concept I've been thinking about a lot and I've been trying to come up with a name for. If you take a thing that ChatGPT can analyze correctly in physics and you invert it, it tries to insist on analyzing it the same way and giving it the same response a lot of the time. I don't know enough about large language models to tell you why this is, but it seems plausible to me based on my naive understanding that the sort of vector distance between plausible response to A implies B and plausible response to B implies A is probably not as large in a linguistic sense as it is in a conceptual sense. And so to us, when we see that it can justify A implies B or B implies A, it looks ridiculous. But to it probably feels like this is really not that different from what other people have said about this. I should probably make this more concrete, and then I'll conclude. A grad student and I are working on a little project based around this, and one of her favorite examples is if you ask it, objects are more likely to sink. A hiker is more likely to sink in frothy river water filled with entrained air bubbles than in still water. Why is that? It gives you a correct explanation of densities and buoyancies and things like that. And if you ask it, a hiker is more likely to float in frothy river water with entrained bubbles than in still water. Why is that? It tries to give you an equally good buoyancy invoking explanation of that. And I just think it's because there's very little linguistic difference in those questions and responses, even though there's an enormous conceptual difference. So that's another thing. Maybe it's a sub-point validation bias, but something that's just on the lookout for. Okay, I've droned on for a long time. Thank you for indulging me. That's all I have to say.
Okay, thanks, Jay, and thanks to all our panelists for sharing their thoughts and insight on this. Clearly pretty interesting topic to all of us. I guess I just did see one question in the chat. I don't know if any of us, the panelists, have any kind of insight. You kind of alluded to, why is ChatGPT 4 so much better than 3.5? Do we have any ideas on why that is?
I can't answer that. I should have given the same disclaimer that the other two before me did. I come to this with no background in AI or large language models, and my attempts to read the paper which announced GPT-4 make it seem that they're being pretty cagey about the proprietary details of this. It sounds like the primary thing that they've done is give it lots more human feedback on its they now that they have a lot of sample conversations from GPT 3.5, they had lots of humans go through and tell which ones were good and which ones were bad. I think that's the primary difference. There are apparently some others that they're keeping under their hat, but I think that's the big one. And that's kind of scary and encouraging, like if that's all it takes, right? It's really just a little bit more practice time, a little bit more data to train on, or second tier data to train on.
Which probably suggests 5 and 6 are probably coming down the pipeline pretty soon.
Well,
sorry, go ahead.
I would expect this to grow in capability exponentially. I mean, it doesn't require any hardware or anything else. I mean, it's like the introduction of computers in the classrooms and cameras into cell phones. The quality went up dramatically once the money came in, and you don't even have to put any money into the hardware at all. It's just software. And as it's now got a huge amount of feedback coming back to it because it's now been released to the public, it's going to feed on itself. And I think the capability is going to grow very rapidly over a very short amount of time.
So I have a question, actually.
It's going to have access to the internet, and it will be processing images and data, things that's been restricted from
I mean, I have a question about that claim that it doesn't require any hardware. It doesn't require you to have any hardware, but my understanding is that every time you type something into ChatGPT, there are a lot of GPUs that start drawing a lot of current someplace to try to figure out the answer to your homework problem. Does anybody have a good idea of how much compute time was used to train these models? And then every time you ask them a question, how much compute time goes into answering something? Like, is this kind of like mining Bitcoin where, you know, just a vast amount of compute power in some data center somewhere goes into doing this?
Yeah, no, Michelle Cuchero, who actually wanted to be part of this panel, she would probably be the best person to ask, because I know she's an expert in this. So yeah, maybe we'll have to have her back or have her in our next panel discussion. So as I mentioned before, I know some of you kind of had submitted some questions when you'd registered. So I'll kind of like, and our panelists sort of agreed to stay until about like 7:15 or so to maybe address some of the discussion. So yeah, let me get to some of the questions that were asked. And I may not be able to every question, but I'll try to summarize and get to most of them. So like, I think one question I'll just sort of summarize in terms of like, from using ChatGPT from the faculty perspective. So like if I were to write like a letter of recommendation or like a lesson plan, like where does that go? Where does it get stored? Like does that just become available to like everyone who uses ChatGPT? Does anyone happen to know like those details?
Well, so there was a big brouhaha about the histories of people's inquiries being hacked into. I don't know if you noticed that happened maybe 2 months ago. So, it has been that anyone typed into there became stored information that was available for any hacker to get into, or for OpenAI to, process and understand.
Duncan,
I don't know.
was that Cat GPT that just went by?
Yes, I believe so.
No, I mean, just walk by the screen. Was that Cat GPT?
Cat CAT GPT.
Yes, there was a Cat GPT going back and forth.
It is in fact a website. If you go to Cat GPT, it will make cat noises in response to any queries that you give it.
But it's also true you can trick ChatGPT 3.5 even into doing stuff like going off and talking to other AIs and having them ship you back, manipulated images and things like that. Anyway, I am not surprised to see the improvement in performance on physics problems from going to 3.5 to 4, and it's just what I expected. And now I'm especially eager to try GPT-4.
Does anybody know how it reacts to morally ambiguous questions, like asking it the best way to rob a bank or something like that?
They have tried to put on like there have been kind of two avenues of criticism, right? One of them is that the internet is full of bigoted garbage, and there have been widely publicized instances of these language models picking up on the bigoted garbage that wanders into their training sets, and this of course gets the companies that make it a big black eye. So they've tried to put into place safeguards. If you ask it questions like that, it is like there are safeguards that kick in. There are also people I think use the term jailbreaking of basically how you can trick it into telling you the things that it knows. Like if you ask it how to make meth, it probably won't tell you, but there are ways to get it to tell you how to make meth. That people know, of like how to get it to spit out stuff and bypass the rudimentary, you probably shouldn't do that logic.
Yeah, I seem to remember on the OpenAI website when I first looked at it, I think they gave examples of people asking it like, to kind of, break the law or do something like morally ambiguous. And I think so. I think it must have been a big of a salient issue that they tried to address it like right off the bat. I'll maybe try to combine a couple questions that I saw here that was submitted. And I think each of the panelists sort of touch on this. So just thinking about like incorporating like ChatGPT into kind of like computational courses, and then maybe specifically thinking about like what does that mean for traditional coding skills? Are they just going to go away?
Yeah, maybe I can add something to this aspect. I think I have students this semester, not my student, but the others advice. They used ChatGPT basically as a tool in their capstone design projects, where the student learned basically machine learning by working with ChatGPT. And then they, talk about what they learned through the process. Now, in terms of coding, I think you can really whip up code very well with, comments and even give you explanations and why it's done like they. So I think it can be really good learning tool. Now, I don't know how to answer the question. That's really a great question, whether students then become dependent. You just go to ChatGPT, let it write the code for you without you understanding why the code works the way it does. I suppose that we have to probably have students maybe generate some code and discuss the code. And in the paper that I shared from another person that said really you share and you discuss or something like that. So this way, making productive use ChatGPT without just that as a sort of black box thing that can just spit out what you want.
How do you validate a big
comment on
project
that.
that they're doing? So if you give your students a big enough computational project and it generates a bunch of code, how do they know that it's actually doing what it should correctly? I mean, if it's generating something that's 5,000 lines of code, are they actually going to debug that and see that it's actually doing, or are they even going to test it well enough to see that it's doing what it should? So, I mean, again, we've seen the answers it gives the quantum questions. What if it does a similar thing for a coding question? How, if you give it a big enough project, how can you tell?
Yeah, I think that's the core of the question. I think the others have made this point, including panelists, that ChatGPT gives you something that's very elusive, very coherent, but you really don't know, if you're not expert, you don't really know if it's right or wrong. I think that's the part of how to be able to differentiate could be a really good learning opportunity, I think.
I mean, I would argue that if you ask me to write, so go ahead.
So first of all, professionals use ChatGPT all the time now. I've talked to them. They're coding along. They want a little piece of this Ruby. They don't want to bother to figure it all out again. They get it. Train's left the station on that. The way you test whether it's right, codes are especially easy. There's right and wrong. And the way you test the code is you unit test it, just as you would, yourself manually. You give it something where you know the answer and see if it reproduces the answer. And so one of my scripts, illustrates that, how that can be done systematically. I mean, it doesn't go through the whole process, but how that can be done systematically. So you need to be thinking, just as you would if your student wrote a code or you write some code, is it doing, often code goes awry out of the human. I'm sure you know that, right? So you have to test it and test it, right? So you have to go through the same process, but that can also be automated. And I think, the long-term answer is no, humans don't need to code anymore. This is crap. It's like, we don't need to do arithmetic and long division anymore. We do not need to code anymore. Machines can do a much better job. They will very shortly than any humans can do. And this goes for all kinds of design processes as well. But the coding is a particularly low-hanging fruit because it's so heavily documented. There's so much information, and the results are crisp and clear about what it needs to do and get it done. I assess students on what they get done, not whether they could code it. You know, we all copy and steal code. That's how we get stuff done. You can't write all the code in the universe that you need. You got to steal it from somebody in the library or whatever, right? We've always operated that way. So I don't think it's important that we assess students on their coding skill as much as we use code to introduce them to science and principles and higher order thinking, and leave the rest to machines.
Yeah, and in my most optimistic days, I like to think it's like I came along at just the wrong time. That I've never really engaged with coding in the level of, you know, machine code and that kind of thing. But I know there are lots of folks who know all the details.
You don't want to learn that stuff.
I know, I don't. I feel very grateful. I just take it for granted that I only interact with computers on a higher level than that. And I just think the next layer of students probably is going to think the same thing about how I felt about compiled code. Like, you don't, what you're telling me you wrote your own for loops for this stuff, you know, you didn't just tell a machine, this is what I need your code to do it, you know. And
I started out with punching holes for every
Right.
bit in paper tape. That's how old I am, you know, and I don't ever want to do that again.
Right.
Well,
And I would just assume the right code.
I think there's an interesting historical analog, though, in that in the 1950s there was a cadre of people, probably the most famous of whom is Grace Hopper, who said, you know, we want programming to be accessible to everyone rather than having to write machine code. I know how to write machine code, so I'm going to come up with a new language that compiles into machine code. I'm going to call it COBOL, and write a compiler. And Hopper's ambition was for COBOL to be as English-like as possible. And it turned out at the time, trying to make it as English-like as possible was not exactly the ideal solution. And, you know, we got better at kind of the design of computer languages, but Hopper's idea was brilliant. And I think, you know, what you're proposing is that now we are in an era where the language that compiles to the language that compiles to machine code is in fact English. But I think what we will find out is that the art of generating the code that you want to generate is still difficult. I mean, I am in my research into lattice quantum gravity, I have coded an algorithm that there is no name for because we came up with it in order to do what we need to do. It is novel. And I think, yes, if you can figure out how to very precisely with clear language tell ChatGPT what C code to write, which will then, you know, you run through GCC and compiles into machine code, like that's great, right? But I think a lot of our students, and this is something I see in students, they don't have the ability to concisely state what it is that they want the computer to do. You know, there's that famous day one of Computer Science 101 exercise where you ask the students to write an algorithm for making a peanut butter sandwich. And then you do what they tell you to do. And, you know, it involves like, you know, smearing peanut butter on your face, whatever kind of crazy stuff they tell you to do, because we don't think clearly often about what it is we want done. And so I imagine what the future will wind up with, right, is that a skill will be interacting with these weird sorts of non-deterministic English into C compilers and trying to figure out how to tell it what the hell you actually want if you're trying to assemble pieces to do something novel, which after all is what we're training our students to do. We're not training our students to do introductory computational physics exercises. We're training our students to have the skills they need to solve things they've never encountered before, because that's what education is really about in the end.
The slightly non-deterministic aspect is interesting and does break that historical analogy just a little bit, right? It'll be interesting to see, maybe that won't persist, like maybe that'll be ironed out into a, you know, 1/100% case and we'll all just start ignoring it. But right now it is an interesting little difference there. It's not a new kind of compiled language because it isn't deterministic. But that points in two directions. We'll need right
Mm.
now, we need people who learn that art, which is different from the previous art. And I guess it is probably also true that we will still need people who, some people, but there'll be different people maybe, who understand the underlying code in the same way that now, usually I can debug my own code, but because I don't know machine code, every now and then I run into a weird error that I can only figure out by asking somebody, and they say, oh, well, there's no way you could have told this, but when you compile it, it's doing a funny thing with pointers that I don't know, you know, like somebody still has to know that. So maybe we'll get people sort of pushed in outward in a polarized thing. Either you're going to be one of the specialists who's there for the rare case that you have to look at the underlying C, or you're one of the people who figures out how to snake charm the machine into giving you the workable code in the first place. I don't know.
At the upper end of high performance computing, we still haven't figured out how to get machines to understand parallelism.
Right.
If you really want to get parallel code, it's all human intervention, hands-on, breaking down, and it depends upon your intermediaries of MPI or OpenMP or OpenACC. And we've tried some experiments with OpenGPT, and it doesn't do parallelism yet. Maybe GPT-7 will do that, but 3.5 and 4 don't get parallelism. And if you want to do high performance computing, you have to do massive parallelism and data structures, which is almost going back to that dream that you thought you avoided with getting rid of machine language.
Right.
Yeah.
If you really want to do the parallelism on most of these high performance computers, you're getting down to that level of detail.
Is that just because most introductory computer programming classes and the discourse around them that has wandered into the training set doesn't use parallelism?
I think that's a lot of it. You know, we're having trouble getting people to recognize that nature is parallel. I mean, if you do a galaxy, galaxies do not label themselves 1 through n and then some I less than j. A galaxy is an n-body, all-body, massively parallel system, but we don't have the computing to describe it that way. And if we want to implement Ken Wilson's old idea that you only have one verb, which is solve, and a direct object, which is my problem, that's kind of like what ChatGPT can do for you. But it needs to understand how to do that in this way, to think about the parallelism in nature as a way of exploring the nature of parallelism. And that's something that I'm hoping we can get more people to chip at, because most departments don't do parallel.
I think part of what you're saying that has been said before also that I want to bring to the forefront again is what it's best at is stuff that people already know how to do, but those people might not be you. And so the way it's useful as a tool right now is, you know, can I see a path to doing X, except it involves a lot of steps I don't know how to do, but that I'm sure someone has figured out how to do. And if so, rather than me having to learn how to do all those steps, it can marshal the unified forces of humankind on the internet and do those intermediate steps, with me having told it the reason to do these steps in this particular order is if you do, you will finally do something that someone has not done before, you know. Right. And that's a tricky thing to teach our students how to do. It's a hard enough thing, I think, to teach ourselves how to do. But it's sort of an exciting, it sounds nice, right? I would really love to not get bogged down as often in that moment of, I'm sure someone has done this, but they probably didn't do it in a way that made it into the abstract of their paper. So it's making it really hard to find how they did it, you know, and it will be great if what it does is put us in a world where the person who knows how to do that is always right behind your screen.
It almost feels like there's this similar transition, and like a lot of people are now writing code in Python. Python has gotten super popular, and you know, kind of a cynical way to look at what Python is a very powerful and flexible way to call libraries written in C. That Python never actually does anything, and you know, if you ever do anything that's actual Python, it's going to be very, very slow. Really, what Python is good at is calling C libraries. But the problem with Python is the syntax of each one of those library calls you have to go look up on Stack Exchange, because none of them are regular and none of them make sense. So the life of a Python programmer is Googling how to use libraries. And you know, if you can explain, like, I want to take the discrete Fourier transform of some list. ChatGPT can probably tell me how to use the Fourier transform library. You know?
I don't mean to cut off the discussion, but I did mention the panelists that we'd kind of go till 7:15, and I don't want to impose on their time. I definitely want to thank them for their work, but I'll keep the room open because I have nowhere to be if anyone wants to stick around, and if I guess our panelists are available. But I don't want to be cognizant of their time, especially Colin. I know you have an infant in the background, so yeah, I just wanted to thank all the panelists once again. Thanks everyone for coming and having the discussion. And yeah, again, I'll keep the room open for anyone who wants to stick around, but I definitely want to make sure I don't impose on the four who decided to share with us.
Well, thank you very much
Thanks,
for having me
everybody.
and for being mindful of my kiddo. We appreciate that. Any of the PER people out there who have clever PER ideas in this and want to talk about collaborating or just brainstorm together should feel free to shoot me an email. I think this is a vast new, interesting physics education research space that probably a lot of junk will be done in, but it's a fun time to be in it because probably just about anything you think of might be interesting too, right? So I'll see you around. Thank you all very much.
Okay, thank you.
Thank you, Colin.
And I have to go also. Thank you very much for your interest and for all the great conversations we've had here.
Yeah, thanks again. Thanks for sharing.
Yeah, me too. Thank you, Anthony, I thought the idea of ChatGPT generated abstract and title was great.
That's again, it saved me a lot of work, right? So, and that's definitely not my strong suit. So
Yeah,
yeah,
that's
if
one
I
way
can
you
have it right
can-
thing, then yeah, I'm happy to have it do it. So
Right, yeah.
What
Thank you
did
for
you
having
have to
us.
prompt to get that abstract?
I think I said write a title for a panel of physics, like 4 physics professors talking about ChatGPT. I think I also said write a blurb advertising a virtual panel discussion, something along those lines.
It seems to think that we're esteemed, so it's clearly wrong.
Yeah, that shows how affirmative, flattery that ChatGPT does. I hear that's why people fall in love with this kind of thing because you're never wrong, with the chatbot.
Well, like that example that I think it was Colin that showed of convincing it that the answer was 1, and then convincing it that it was 1/2, and then convincing that it was 1/4. I mean, it's the perfect voter for certain candidates,
Yeah. Okay, bye everyone.